What's up, everyone? Today we're going to do a titration problem where we neutralize an acid or a base and we draw the little curve and we figure out the math behind this. So this is the only kind of titration stuff you need to know, which is equivalence point math. This says 160 milliliters of 0.35 molars HI, that's an acid. All of this acid is completely neutralized by what volume of this molarity of base? Okay, let's do this. So I have a base being added to an acid. I'm not sure what volume I need, but I already know the volume of the acid. Now, at the equivalence point, or at the neutral point, remember, strong base and strong acid. So if we're strong and strong, our neutralization point is also the equivalence point. We know that the moles of our acid, or specifically our moles of our H plus, are going to be equal to our moles of our OH minus. So that's the first thing that you have to know with these things. All right, so now we're going to figure out, okay, what does this mean? Well, I can just do concentration times volume. Concentration times volume is just moles. So my concentration times my volume of the acid should equal the concentration times the volume of my base. But be very careful here. In order to do this right, you need to know the reaction here. So I'm going to write the reaction down. I have HI, and to the HI, I'm going to add my barium hydroxide. Now, hydroiodic acid and barium hydroxide are both strong. So this is going to be a perfect neutralization problem. BaOH2 here. And my products are going to be, well, it's double replacement. So here we go. We take my I and my barium. They're going to be friends. And they make a salt. But keep in mind that barium has a +2 charge, whereas iodine only has a +1 charge. So for my products here, I need 2 iodines for 1 barium. So BaI2 is your salt. You also have water. Now to balance this real quick, so I have H2O, HI, those both need to double because I have OH2. OH2 is going to mean my oxygen has to double, so my water has to double, as well as the HI. This is the pattern you're going to see for every single titration problem where you have an OH2. Well, let's do it. So how do we solve this thing? C1V1 of the acid equals C2V2 of the base, except, here's our problem. I have my 2. And if I have a 2 in front of the acid and no 2 in front of the base, we care about the moles here, right? So mole ratio is 2 to 1. I have to either cut the amount of acid in half to make this 1 to 1, or I have to double the base. You can do either way. It's going to work the same. Doubling the base, I think, is easier, because if you double the moles of base, now you're 2 to 2, which is also 1 to 1. So let's do it. Some of you know this as M1, so I'm going to do M1V1, and this is my acid. That's my HI, equals M2V2 of my base. But we said we either have to halve the acid, so divide by 2, or double the base. Either way, it's the same. Let's double the base. Now we just plug numbers in and we solve. So my acid volume here is 160 milliliters. My acid concentration is 0.35. So this is going to be 0.35 molar. Okay, times 160 milliliters. Okay, this is my acid. Now let's do the base. Equals 2, because I'm doubling. You only double one, you don't double both. Okay, don't double both the concentration and the volume here. So 2 times, well, we don't know volume. So we want molarity here. So 1.5 M times V2. A lot of numbers here. Solve, plug and chug. So on my calculator, I'm going to do 0.35 times 160, and you can keep this in milliliters because it's your C1V or M1V1 equation. Multiply 0.35 by 160 and then divide by 2 times 1.5 is 3, so divide by 3, and I'm getting 18.67. So looking at sig figs, I got 2, let's just leave it at 2. So 18.67, 19 milliliters, and we're having a good day. So that's how much base you need in order to neutralize the acid. Now, when you do something like this, a neutralization problem, you sometimes will have a titration. So as you're adding more volume of base to this reaction here, you are going to see the graph. And the graph looks something like this, where you have the pH kind of staying consistent until, it just shoots up like that, and then it curves off. There's your titration curve. Now, for a strong acid and strong base titration, your pH at the equivalence point should be 7, should be neutral. So this pH here equals 7 when the moles of acid equal the moles of base. So the moles of H plus equal the moles of OH minus. This point right here is called the equivalence point. Now the equivalence point, you might think that's exactly when it changes color. You would be incorrect. The equivalence point is when the moles of H equal the moles of OH. They call the color change the end point. Even though it's on the same steep line, it's going to happen at the exact same time. The color change and the equivalence point are both happening in the same drop. The thing is with phenolphthalein, which is your pink stuff, phenolphthalein turns pink around pH of 8-ish. So that's not your equivalence point. That's a little bit past it, but it also happens during the same drop of base. So because of that, a lot of people confuse equivalence point and end point. Just know that end point is when your color changes, and equivalence point is when your moles of H equal the moles of OH. There you go. That's it for today. Good luck on your test. Hey everyone, so I just wanted to show you one more thing about titrations to actually see it in person, especially if you miss lab. So I have chemical to waste, so let's waste some. I have HCl and I have NaOH. The concentrations right now, they don't really matter. I'm just going to use some. So I'm going to put some in this lovely, nasty looking beaker. I'm going to use some HCl. You know what, let's just use the rest of it because this stuff's nasty. All right, here's the HCl. This is acid. It's going to have a low pH. This is a pH meter, and when you turn it on, it reads the pH. So you're actually going to be able to see this happen. So when I stick this in and I wait a few seconds for the pH to be read, pH should be exactly 0 because I made this 1 molar of HCl. And if you take negative log of 1, you get a pH of 0. So if you see here, this pH is exactly 0, which meant I did a damn good job making that concentration. So, well, what I'm going to do is slowly add the base. And before I slowly add the base, let me add phenolphthalein to it. Now, phenolphthalein is an indicator that turns pink. And it turns kind of milky in there. It turns pink after the pH reaches about 8. So basically, right at the equivalence point, it's going to change. So this is my pH of 0. I'm just going to add a little bit at a time of sodium hydroxide, and we're all going to watch the pH meter here and the color. 0.00. There's my liquid, and there is my pH. Let's add some base. Little bit at a time. Ooh, it just turned a little pink and then disappeared. So if we mix this, the pH should change a little bit, but not that much. Well, it still says 0. That's great. All right, let's try again. There's some more base. There's some more base. See, it's pink, but it's disappearing. So the pH is still pretty much at 0. It's just like, it's not quite there yet, but here we go. Let's add some more. the pink goes away. See, it's still pink, but look at my pH. My pH is climbing, but rather slowly. So let's just keep adding this until it works. Whoa. Let's see if we hit it. Let's see if we hit it. Let's stir. And bye-bye, pink. All right, so we left the... See, there's nasty stuff in here from the old acid. All right, my pH is 0.61. Now, if you notice, it went up, but not by that much. So let's finish this off here. Let's just dump a bunch of base in. I don't need it to be perfect. I just need the pink color. Whoa, I just need it to stay. So let's... Look at the pH. Barely any base was added there, and the pH jumped from pretty much 1 all the way up to 11. And if I add a lot more, the pH, it goes up pretty significantly. We're at 12.55, 12.62, and eventually it's going to kind of flatten out right around 13, I believe. Yeah, it doesn't go up by that much anymore. So that big jump there, that's your equivalence point. In the middle of that big jump is your exact equivalence point, and right as this color changes is called the end point. So there's some titration stuff for you. Now, phenolphthalein, not the only indicator. There's other indicators out there that turn different colors depending on whether it's acidic or basic. So the one we use is just the pink one because it's fun. Also, because it turns pink at that 8 value, it should be right at that equivalence point. So that's why we use phenolphthalein. All right, there you go. Peace.